until somebody gives me a fleet of minions to do my grading, it takes some actual time. So, we shouldn't need to check 711. We should be able to dive into 713, but who worked on 712 last night and noticed there was a quartile problem on it? Yeah, it's okay. If you didn't work on 712, you didn't notice it, but what we highlighted yesterday, right, all this interquartile range stuff, this is on last night's homework. Hey, Vincent, so to comment about on your test where you said you think you're giving 40%, maybe stacking highlighters instead of listening to what we're talking about could help increase that 40%. But I disagree. I think you're probably giving more than 40% effort. So guys, if you haven't looked at 712 yet, and this is not like, and I told you so, this is, I want you to be prepared. Down here in problem 26, and we'll go over this tomorrow, but I'm not going to do this for you. You need to, in order to do problem 26, probably go look at your math notes box that we highlighted up yesterday. Today, so that we're ready for the 713 homework, everybody look at 713 on the back. You'll need to complete 38 on graph paper. Trust me, it will make things easier. You don't have space on this paper. So first off, stop when you're tempted to ignore my advice. Do these on graph paper. What are the these that we're doing? Make a stem and leaf plot. Make a histogram. What's a stem and leaf and what's a histogram? It's a good thing we have a math notes packet where on the back of the front page, everybody find histograms and stem and leaf plots. Histograms and stem and leaf plots. It is on the back of the front page. So it's like page 2. I should have put numbers on these pages. It's like page 2. All right, guys. I just need to throw some information at you, and as I'm grading your tests and people are asking me to like do problems with circles and other things that like we don't know about yet, this is also why I made you this packet, because I know we don't know about this stuff yet, but if you're coloring on your fingers with a highlighter right now instead of listening, it's not going to do well for sticking in your brain. So listen, highlight, ask me questions if then you have questions. A histogram is similar to a bar graph in that each bar represents data in the intervals of numbers. So these bars, guys, the word frequency is a fancy word for how many. So grab your pencil, especially if you don't know this word yet. By frequency, I would write like how many. How many. Frequency stands for how many. The x-axis, or you're like the bottom of our graph, is always going to be the thing we're talking about. The y-axis, or how tall our bars are, is always how many. So from this histogram, which section has the most? 0 to 15. Be careful. This section is a range, and that's the biggest thing people goof up. Intervals for data are shown on the horizontal axis. Intervals. It's ranges. So this is how many kids or people, right, live 0 to 15 minutes to school. How many, then we bump up to the next section. How many live 15 to 30? How many live 30 to 40? It's ranges. So you would fall into one of these ranges, right? You can probably think right now, how long does it take you to get to school? And you could like put yourself into one of these bins. Sometimes these are called bins. I don't know why we call them bins, but bins are where you put things to like organize them, right? So sometimes we call these bins. So, hey, the labels on the horizontal axis represent the lower end of each interval. For example, the histogram at the right shows that 10 students, so if we look at this range right here, in this bin, 10 students take at least 15 minutes, but less than 30. So the 15 is included in this bin, right up here, but the 30 is not. It will be included in the next bin. So the 30 will go up to the next bin. The 45 will go up to the next one. So if you want to give yourself some color coding to kind of remember. And guys, that's because we start with 0 being part of this bin. 0 is part of our first bin, so then all of the next ones kind of, they shift like kind of to the right. I don't know, my hand motions are probably not helping. It's like that constant kind of, if this bumps to the right, they all bump to the right. So a histogram is how we show how many fit into each section. Now a stem and leaf plot is almost the same thing, except we actually see the numbers. So let's move down and look at a stem and leaf plot. Guys, I love stem and leaf plots. And what really makes me mad, no one taught me about them when I was like your age. I didn't learn about these till I was in college. Same for you, Miss Martin. I don't know why. Like, I think at some point, probably maybe a kid was like, hey, I could organize data like this and it's a lot easier to write it out. And mathematicians and teachers were like, you're right, let's do it. Because if it makes sense, we should do it. So check it. You have this whole list of data. And somebody says, write all those numbers out, but make it easier to see where the numbers are based off their tens. Right? So like 49 is the only 40s I have in my data. But 52 is not my only 50s. Right? So we're going to sort our data by their tens. So this key tells us 8 on the left side of the line means it's the 80s, and a 2 on the right side of our little vertical bar means, okay, 2 is the ones place. So if you want to make a note to yourself, the left side here is like our tens or sometimes even like our hundreds places, but the right side is always our ones place. So the note that I would make on here is that, ones place. So that right here, the last digit, if you're highlighting the last digit of each of the numbers, and that is what we call the leaf. So the stem is like the major part of the numbers, whereas the leaf is just the ones place. So a lot of times we're using the stems as just the tens place, because sometimes it includes the hundreds place. Sometimes it includes the thousands place. But what always stays the same is the leaves. Those are always the ones place. So guys, if I highlight this 7 and this 8, what number actually is that? That's 78. So which set of tens has the most frequency here? The 70s. And I can see that really quickly. Which set of tens has the least frequency? The 40s. Now you want to see something cool? This is a histogram. Watch. Give me your eyes up on the screen real quick. I know you're highlighting, but give me your eyes on the screen. Remember this right up here, this histogram? Watch what happens if I take the stem and leaf plot and turn it sideways. 40 up to 50, 50 up to 60, 60 up to 70, 70 up to 80, 80 up to 90. This is a histogram. If I turn all of these into like frequency bars, it's a histogram. A stem and leaf plot is set up, ready to be turned into a histogram. So if I make a stem and leaf plot, I've essentially made a histogram. I just got to turn it sideways. Questions on histograms and stem and leaf plots, because it's on your homework tonight. Use your notes when you get to that question. And should questions 38 be done on your paper, No, get graph paper. Graph paper. Graph paper. Some of you are going to try to squeeze it onto this paper, and I'm going to tell you, nah, fit it on graph paper. All right, let's look at 27, because that's the first question of our lesson. So you can put your notes away if you want, like the math notes packet, if you want to keep this safe and put it away. Double check that your name is on this. We do not want any no-name packets. We'll go over 712 tomorrow. There will be math lunch today. We ended up having math lunch yesterday anyways, even with the nice weather. I can't convince myself to go outside. I really want to go outside, but if people want to do math, I want to do math. That's the problem. I'm like addicted to math. I know we could do math outside, and sometimes we do, but it's harder to focus. Sweet. Anyone want to read? Aiden, you want to read? You want to do this whole paragraph for us? Thank you so much. So, before we dive into this, need to make sure that we respect each other, because you won't all think the same way. Right? You guys are really good at this. My afternoon class, I have to kind of talk to more about this. But if somebody says, hey, I think we should do it this way, and you think a different way, does that mean one of you's wrong? No. Like, you can both be right and do it differently. So let's check out this first question on our paper, number 27. Hugo and his family are shopping for a new mattress, which now the game's kind of changed. A lot of people are ordering their mattresses online. But as you know, there's like mattress stores, right, where you go out and like you try out the beds. So they've picked out their bed. The bed costs $245. That's actually not that expensive for a mattress. Mattresses are pretty expensive. But they're on sale. Mattresses right now are 60% off of the original cost. I want you and your team to discuss how can we find the sale price of the bed. I'm probably going to try to give you like an honest 5 minutes. So chat with each other. How can we find the sale price? It is 60% off. And you're going to need graph paper after this problem, so if you don't have it, get some. Dig the jacket, something going on there? All classed up. Oh my gosh, that's awesome. Right? 60% off.
Yeah, we can talk about that. She talked about like, you know how you do the line where we have like the percent on the bottom and the cost on the bottom. Sometimes it's in your homework. That's what she just
Notice that your paper asks you to figure out 2 different ways. So once you all agree on one way, try to find another way.
Let's focus on this.
If you haven't drawn a picture, we love pictures. So you can draw what we have up there. And you should have graph paper on your desk at this point, so if you need more space, you could do this on graph paper. Man, if only there was paper that like had, like boxes on it and made our life easier. It's like living in the future. Lines that go both ways. So one question I start to ask myself is, if there's 60% off, what percent is off? Right? Kind of how I drew it in that picture. So one thing is, if it's 60% off, what percent is off? And you guys discussed that it's like a certain percent off, and that is a certain percent off. Something's off. Where are we divided? When we could. Okay. So that number is what?
So I would probably not do 5.
What is that? Is that the price they pay or is it? So then what would we still need to do with that? So I wonder if there's a way that we can get right to the answer without having to do a subtraction.
Oh, yeah, sorry.
Got it. Very cheaper than that.
30 seconds till we'll come back together. I want to start giving you guys a warning.
Excuse this interruption. Could I please have Samaje's story to the Perry office for just a moment? Samaje, to the office, please. Thank you.
All right. We said that we're going to use cards and be honest, so until I hit that Post-it note, we're still going through the deck. Remember, you can skip or pass, whatever you want to call it, but then I'll shuffle your card back in. Cade, what did you guys talk about? I mean, you can just lead us off, say whatever. You can. You'll get shuffled back in. We'll come back to you later. Franco, what did you guys talk about? So wait, 0.60, where did that come from? So Franco said, wait, so what does percent mean? Out of 100. So Franco set up this and turned it into the decimal form. So you said do that times what? Times 245, and I think you got like 147. I only know that because I looked at people's papers. Guys, I used to think my math teacher was brilliant, and then I realized he walked around the room and looked at our answers. It's no big secret. So wait, is that how much they're gonna pay? Actually, I'm gonna move on to another card. So Jesus, is the 147 what they're gonna pay? Yeah, that's the sale of how much they're gonna save. That term is used weirdly. They're gonna save. So what do I do with that 147? We subtract it. So we do 245 minus 147. And they're getting this mattress for $98. Make sure we label it. Yeah, maybe it's like an end of season clearance or something like that. So this tells us this question mark, right? Is 147 that they saved, 147 that they didn't have to pay. But guys, I walked around and I asked this to most groups. I think there's a quicker way. I think there's a better way. Okay, Mr. 40%. Okay, so can I just tell the class why I'm giving you a hard time? On the test where I put, like, how much effort do you think you're putting into your homework and stuff, Vincent made the joke of saying, I think I'm putting in 40% effort.
I meant to put 90, but I think you misread it.
That makes more sense. Because I just assumed it was a joke because, you know, Vincent is making up strategies and things like that. Hey, group with Play-Doh, we're going to need to put that away. It's getting too distracting. So gather it up, put it away. It's also germy. Because if you guys haven't all just washed your hands, you're all sharing germs with each other. So we're not getting off task because we're getting them back on task. Vincent, what do you mean that there's an easier way?
So,
Easier.
if you, so 245 is 100%. If you divide that by 100%, I mean 100, you get 2.45.
So, hold on. So Vince, absolutely, but I want to make sure everyone's with you. Vincent's telling us if we divide by 10, we could get 24.5, or if we divide by 100, we could get 2.45. So what would that be, Vincent?
1%.
That is our 1%. If we divide by 100, that is 1%. What are you going to do with that, though?
Multiply by 40 and by 60 to get 4%.
So actually, I want to go back to your original method of the 10, because if we're trying to get to 40, do I need, like, I could use 1%, or I could use 10%, right? So Vincent's saying if I want to write it down, 2.45 would equal 1%,
24.5 is 10%.
or 24.5 is 10%. I got too many dots up here. There we go. So, like, I can make all these notes somewhere on my paper. So wait, you're going to try to get to what percent now?
40.
Why?
Because that's the sale price.
Hey guys, if there's a percent off, there's a percent on. So I want you to make a note in your paper that the 40% is our percent on. Right? People like to talk about what percent is off. Okay, great. That means a certain percent is left on. That's the percent you gotta pay. So if 24.5 is 10%, how can I get that to 40%? Multiply by 4. And that times 4 gets me $98. Now, if we have a calculator, guys, I don't like saying bad words, but, you know, sometimes situations call for bad words. This problem's easy.
I said that word like 5 times today.
If you have a calculator, hey, asterisk, like, you know, special star. If you have a calculator, all you have to think about is what percent is on and do that math. So instead of doing 0.60 as the math I do, what percent did we say is on? 40%. So you could, in your calculator, just do 0.4. I'm going to change colors because I don't like that I'm writing this in red. You could do 0.40 for the percent on times the original price, and that will jump you right to your answer. Gets you right there. No subtraction, nothing else. One step. Easy. It is. It's one step in the calculator. It's just, Layla's very mad. I'm kind of scared. It's easier than most things I ask you to do. Yes. Questions? Questions, because we're doing more of this, so you're going to need your graph paper. All right, this is 713 if you didn't label it. 713 if you didn't label it. But do you think I'm going to give you the exact same thing again? Well, let's practice one more with the same thing, actually. Let's do this. Let's try this. We're going back in time a tiny bit, but try this. If the computer is 35% off, talk with your team. How can we solve this? If the computer game, sorry, not the computer. So, hold up, because you can't see all of this, and I want you to write it, like, you might want to make a note right now. Your original price is $40. Original price is $40. If you want to number this, this is number 20. I'm going to write that down. That the original price. Original price. Talk with your team. If it's 35% off, how can we solve this problem in like one step? Now, be careful, 35 is not as nice of a number as what we just worked with.
Yeah.
30 seconds, because then we might as well talk about this together, because we said this is easier than the other problems. So the original price, what percent do we say the original price really is? The original price is 100, right? It's 100%. The original price is 100%. So our 100% is $40. Lucas, if it is 35% off, how is your team going to find the easier route to the answer?
You could put 0.35 to 35 times 40 in calculator, put parentheses, and you get our answer. Type in the answer.
Sure. That's not the answer, though. That. Hold up. I got cards. Layla Davis, what'd your team do? Hold up, Layla, say it again, but without the...
I subtracted the 35 from the 100 to get 65%, and then I multiplied 65 like 0.65.
Now wait, why'd you do this? This is 65% on. If it's 35% off, it's 65% on.
So, and then I multiplied 0.65 by 40, and then I got $26.
So, would Lucas have still gotten to $26 if they subtracted 14 from 40? Yeah! So, are there multiple ways to get to the right answer? Yes. In my humble opinion, this way's better because it's faster, right? IMHO, as the kids would type, I've heard. Guys, I feel like every day I have to learn a new acronym. Makes me feel It was like last week that I learned what IRL meant. I felt real dumb.
In real life?
Yes, thank you, I know now. But I'm not on the internet that much.
I'm private IRL.
So, the two ways. Me realizing what IRL means, like I feel like I need a meme. Okay, either calculate how much you're gonna save and then subtract it, or figure out what percent is on and solve that. Questions? We're changing up the problem type. What if now you have gotten yourself a summer job? Yeah, making money. And you did so well, they're going to give you a raise.
3K.
Talk with your team about how to figure out the new pay Sandra is going to get at her summer job. Guys, if you get yourself a good summer job, you could make $3,000 in a summer. You really could. I know Miss Hauer works at the zoos over the summer. I build stuff for people. I have stopped working like a specific job. I might be building tiny homes this summer, actually. But like a summer job is a really good idea. Yeah, if this woman gets this little farm, she wants containers turned into tiny homes. So like those big shipping containers. Because guess what? It's all math. Everything's math. All right, I should hear you guys chatting with each other. You got calculators. I should hear some buttons being punched. Now, if you start talking about the percent on here, is her pay getting decreased or increased? Increase. Our percent on is going up, actually. Our percent on is going up. Draw that diagram on your graph paper. Makes sense. Oh, you found one. Like I hear myself now. Right? Those numbers like I can never tell if kids are taking or if I'm just still similar to kids. Now, I feel like Vincent was kind of prepping us for this problem. We could find 1% here. You did the 1%? Sorry. Who do I feel like you look like? Is it Harry the Platypus? With the hat?
Oh, yeah, I see that.
I feel like is that who it is that has that hat?
Yeah.
He doesn't have two hats, though. Probably not. Because I was thinking of him, like, who does Vincent look like? I can't think of it. All right, Aiden, in about 30 seconds. So, you want to check all before what you do? Sweet. No, what is it? What is 3 times 6? Yeah, I know. So forget about the 0%. What's 3? Right, yeah, that might double check that. Everything else you did, I love. All right, Aiden's gonna take it away.
What?
I told you in 30 seconds you're gonna take it away.
All right.
Yeah. Ah, y'all aren't ready for the second laugh. All right, Aiden, tell us what you did.
So since 3,100%, that's it.
Hold up, people are talking. We're listening to Aiden now. All right. 3,000 is 100%, and we would have labels on those numbers, right? Aiden didn't have labels. That's how I'm giving him a hard time about that. All right, go ahead, Aiden.
Okay. Lily, mind the beeswax. Anyway. So to get to 1%, divide by 100.
So, actually, on your paper, I love what you did first. You just kind of chipped your way down there. Aiden had divided by 10 to get to 10%, and this would be 300. Then he did it again. Sorry, you take over.
So 10% divided by both sides to get 30. Then times 6 on both sides, and you get 180 over 6%.
Ooh, and this is dollars.
Don't forget the rest. Now I'm giving you a hard time. Anyway,
Oh, yeah.
so 180 plus 3,000, that would be.
Oh, so then Aiden says, so then add it to 3,000, because her pay is going up. And what do you get?
You get 1,180.
Or John's just going to shout it from the back of the room because he likes spoiling the movie. John, I'm never going to the movies with you. Layla? Hold on, Layla's trying to quote my words back to me. This should be pretty good. You're right. At the beginning, we should establish what goes where. And then you're right. I wasn't going to push back on Aiden, but I don't care as much about these labels till we get to the answer. But when you write down your first... Hey, hold up. Because this is a good point to talk about. When you first establish what goes where, we should put labels on. Then it doesn't matter as much because they have the same labels. And then we should label at the end. Mia? Yes. All right, but there's a better way. Do you know it? Because I'm going to ask about percent on.
Times point. Times point 96.
That's the same way, essentially. That is what 80 is. That's right, but that's essentially the same way. Hold up. A 6% raise. What is that doing to our 100%? It's going up. Hey, unless you solved it this way, you shouldn't be talking, you should be listening. So here, if we think about the percent on, my percent on went from 100% up 6%. What percent is on now? 106! Guys, please write this down on your paper. We have 106% on. You can do this in one calculation. In your calculator. How do we... Hey, cool it. You're going too far now. 106%. What is that as a decimal? 1.06 in your calculator. If we do 1.06 times our 3,000, we do 1.06 times our 3,000, we will get right to our new answer of $3,180. In one step. But did we get the right answer the other way? Yes. So do both ways work? Absolutely. But I think this one's better. It's not right versus wrong. It's just that one's quick. Now, it's not a race, right? Quick is not the goal. But if it's quick and it's comfortable, like if this makes sense to you, I don't know why you would make things take longer than they could. I'm all about, let's get this done with. Because we've got 2 months of school left. We should probably try to be efficient. There's 2 months of school left. It's March. So we look right here. We got March, we got April, and then it's May, and we end school right around here. And we got spring break in here. Try this one. I bet you guys can solve this in the 4 minutes we have left. Marina teaches gymnastics at summer camp. She's paid $12.50 per hour. That's the original pay. I scooched this too far. If Marina were offered a raise of 100%, talk with your team real quick. You got 60 seconds to talk about what does this mean. If you were offered a 100% raise. So your card is up next. What are you guys thinking about over here? You're going to go up a raise, right up 100%. What's that really mean? By. So I'm giving you 100% right now. Let's say these 3 markers are 100%. And I offer to give you a raise of another 100%.
So essentially the percent on is 200%. Yes, and we're going up by another 100. We are essentially double. Absolutely. Look, be careful that A word. Sounds like the E word. You just.
All right, real quick, Isabella's going to hit us with knowledge, and then we're going to get out of here. Isabella, you want to tell us what you figured out over there? Absolutely. So, guys, a 100% raise, if you're going up by 100% and you're already at 100%, what's the new on percent? 200%, which they said is essentially doubling. Absolutely. Have a great day. See you guys mañana. I don't know how far we go. Oh, those of you asking to learn circles, we're going to get there next week. I heard you. People on their test are saying, teach me about circles. I got you. Area, circumference, radius, diameter.
Isn't the area of the circle like infinity?
No, it involves pi, but it's not infinity.
Yeah.
This is why I have a job. I get to teach you.
Okay. Thank you, bud.
What? Oh, we're gonna learn about circles. How else can we do pizza math? We gotta learn about circles to do pizza math. Yes, thanks.
You can do it by triangles.
No, they aren't. Square pizza.
How many square pizzas are there really?